Okay, just kidding.
Wait.
Okay, so the correlation, remember,
Oh,
you
yeah,
need to just be able to draw a line through here,
Yes.
right? And that line is either a positive or negative slope. So is this positive or negative?
Positive.
Good.
So
So if you remember the face, right? This is negative, that's positive. So this is a positive correlation. Okay? So this is a positive correlation. Okay? That's half of that problem. The other half is the R value. How tight to the line is it?
Very tight.
Very tight. So that puts it as an R value of equaling a positive R value, and a very tight line is 0.9. Okay?
Cece just said 9.
Yeah. 0.9. Yeah. So remember, the whiter it gets, the more it becomes a 0.8, 0.7, 0.6, and as soon as it gets round and stuff, then it's under 5. As soon as, what I mean by that is, if you got your line and it's looking like this, right? That's what we would consider a 0.5. See, it kind of goes this way, but it's a pretty round, right?
Well, I understand. It's just Cece.
To get to like a 0.1 would be like this. See how that doesn't really have any correlation? The closer you get to 0 is the closer you get to 0. None, right?
What does it say for the second part?
Equal.
Oh, equation for the line best fit. So now we got to come up with an equation. That's the hard part. Okay? This is the easy part. It's really easy. Positive correlation, 0.9, 0.8, whatever. Okay? Now if it were negative, then it would be a negative 0.9. Right? Alright, but we got to come up with a correlation of... So what I'm seeing now, I see that this goes through this point right here. And I don't see it go through another point really. So I see it almost go through this point, right? So then I can draw this line, and I go, okay, that's a pretty good line of best fit. And what I'm saying is it still cuts the values in half. Half of the points are on top, half of the points are down below, right? Plus I'm able to use 2 of these points. Okay? 2 of these vertices. I don't use the actual points. I create my own. Okay? And I look at these vertices, and I look at where they are. And how far does it go from 4 to 14? What's the difference between 4 and 14? 10. So the change in x is 10. Okay? And then what's the difference between 10 and 30? 20. So the change in y is 20. And the slope is equal to the change in y over the change in x. So the change in y is 20. The change in x is 10. Right? So that means the slope is 2. Does that make sense? Okay? So m equals 2. And then what am I using m with? Who knows the equation? Y equals mx plus b. Okay? So if y equals mx plus b, right? I need to find a point. So I take one of these points. Which one do you want to take?
4.
This is 4 and 10, and this one's 14 and 30.
4 and 10.
Yeah, because they're smaller numbers, right? So 4 and 10, that's x and y, right? So m is 2, x is 4, b is b, and y is 10. So what is 4 times 2?
8.
8. So 10 equals 8 plus b. So how do I solve for b?
-8.
minus 8. So I get 2 is equal to b. 2 is equal to m. So y equals mx plus b. Or y equals x. What's m? 2. What's b? 2. It's a different 2, right? So does this cross at about 2? Looks like about 2, right?
Yeah.
So obviously I'm doing this right. I'm good to go. That's the equation of the line. Okay? And that's how you solve for the equation of a line and correlation of R value.